Download this code from codegive.com, link in the description below. Creating a finite state machine, FSM, in PHP can be a valuable way to manage state transitions in your applications, particularly for workflows, game states, or any process that involves a series of defined states and transitions between them. Below is a step-by-step tutorial on creating a finite state machine in PHP 8.3. What is a finite state machine? A finite state machine is a computational model that can be in one of a finite number of states at any given time. It can transition between these states based on inputs and rules defined by transitions. Steps to create a finite state machine. 1. Define state and transition classes. Create classes to represent states and transitions. 2. Create the finite state machine class. Implement methods to add states and define transitions. 3. Implement the FSM logic. Add functionality to update the current state based on inputs. Step 1. Define state and transition classes. Let's start by defining a simple state class to represent each state in your FSM, and a transition class for the transitions between states. PHP. Class state. Private string $name. Public function __ construct, string $name. $this dash name equals $name. Public function getName, string. Return $this dash name. Class transition. Private state $from. Private state $to. Private string $event. Public function __ construct, state $from, state $to, string $event. $this dash from equals $from. $this dash to equals $to. $this dash event equals $event. Public function get from, state. Return $this dash from. Public function get to, state. Return $this dash to. Public function get event, string. Return $this dash event. Step 2, create the finite state machine class. Now, we will create the finite state machine class, which will manage states and transitions. PHP. Class finite state machine. Private state $current state. Private array $transitions equals. Public function __ construct, state $initial state. $this dash current state equals $initial state. Public function at transition, transition $transition void. $this dash transitions equals $transition. Public function handle event, string $event void. For each, $this dash transitions as $transition. If $transition dash get from, dash get name, equals $this dash current state dash get name, and end. $transition dash get event, equals $event. $this dash current state equals $transition dash get to. Echo transition to. $this dash current state dash get name. PHP _EOL. Return. Echo no transition available for event, $event in state. $this dash current state dash get name. PHP _EOL. Public function get current state, state. Return $this dash current state. Step 3, implement the FSM logic. Now that we have our classes set up, we can create an example FSM to demonstrate how it works. PHP / define states. $state A equals new state, state A. $state B equals new state, state B. $state C equals new state, state C. / define transitions. $transition AB equals new transition, $state A, $state B, tab. $transition BC equals new transition, $state B, $state C, TOC. $transition CA equals new transition, $state C, $state A, TOA. / create the FSM and add states and transitions. $FSM equals new finite state machine, $state A. $FSM dash add transition, $transition AB. $FSM dash add transition, $transition BC. $FSM dash add transition, $transition CA. / handle events. $FSM dash handle event, TOB, / transition to state B. $FSM dash handle event, TOC, / transition to state C. $FSM dash handle event, TOA, / transition to state A. $FSM dash handle event, TOB, / transition to state B. $FSM dash handle event, TOCS, / no transition available. Output. When you run the above code, you should see output similar to the following. Transition to, state B. Transition to, state C. Transition to, state A. Transition to, state B. No transition available for event, TOCS in state, state B. Conclusion. This tutorial demonstrated how to create a simple finite state machine in PHP 8.3. You can expand on this by adding features like state entry and exit actions, guard conditions for transitions, or even implementing it as a more complex design pattern. Finite state machines provide a clean and manageable way to handle complex state transitions in your applications.